Let's go over the procedures in Excel to conduct a correlation analysis and a regression analysis. Two related but different statistical techniques. If you're going to do this analysis in Excel, and I say if you're going to do this analysis in Excel, because there are a number of other platforms where you can do correlation and regression. Some are web-based, and you can copy and paste your data into dialog boxes and get the results out. Or you can use other techniques, platforms such as R or other statistical analysis platforms. Those oftentimes require a license, or they are command line driven and have a little bit higher bar than Excel. But if you want to do this analysis, regression, and correlation in Excel, which is perfectly fine, the first thing you have to do is enable the set of tools. Regression and correlation are not an innate function or a set of functions in Excel, but they are a set of macros which you can use to get these statistics calculated in using this spreadsheet program. So as said, this is not an innate part of Excel, but it is an add-on. And the first thing you need to do, assuming you're going to use Excel to calculate these statistics, is enable the data analysis pack. And to do that, you go into File, and down here in Options, and this may be different for Mac users, you're going to come up with this dialog, Excel Options, and then in Add-ins, this is where you can select your tool packs. Now I've got a set of tool packs. These are the ones that are active. These are the ones that are inactive. I've got the analysis tool pack activated here, and there's another one for Visual Basic Analysis that is deactivated at present. Now again, this is a set of macros. That means that it's a set of commands that will perform a specific function for you. And if you have not downloaded this tool pack, the data analysis tool pack, then you are going to need to. And it is not, I believe it is not a default thing that's in Excel, and you would have to download it. If you find the data analysis tool pack in your inactive tool packs, you can go to it, and then you can just you get this dialog box, and then you can turn it on if you like. But we don't need the VBA one. We just need the data analysis tool pack. And we hit OK. All right. Once you have the tool pack added, and again, that's the first step and oftentimes the most annoying, it should appear in the Data tab right here as Data Analysis. OK. Hopefully, that's the hard part. Now we can talk about actually doing this analysis. Before you get started, it's always helpful to get your data organized in the way that you want it. So I've got my data organized here as a table, and I've got the factors that I want to analyze, starting here with regeneration, understory cover, forest floor, so forth. And I need to have the information all the way over here into trees, but I've got this variable called bear, rock, etc., and I don't want to have that in there. So what I'm going to do is, I don't want to lose that information, but what I'm going to do is I'm going to just cut that information. I'm going to move it over, and then I'm going to put this all back together. Excel does not like blanks. You need to be very careful about that, and I caution you to keep things tidy. Okay, so let's do a correlation analysis. Using the data analysis pack, again, in the data tab, I can select correlation analysis. You just click on this data analysis tab, and then a number of tests, procedures come up. The one that I want is right here. It's called correlation. Okay, I hit OK, and this gives me this dialog here. There's this box here for labels in first row. You do not have to use it. I recommend it because I think it makes things a lot easier to keep track of. Now the input range, doing the correlation here is pretty straightforward. What we're going to do here is we're going to select all of the data that where we want to derive pairwise correlation. So that's a correlation of each variable in accordance with every other variable. Let me do the analysis and it will make, that statement will hopefully make more sense. All right, so I hit this, and now what I'm going to do is select the data that I actually want to analyze. And that's a set of variables that you can find in this week's data analysis exercise. I'm going to select all the data. Be careful to select it all and don't select any blanks. And then I'm going to come back up here into this dialog box and I'm going to tell it where to put it. I'm going to select an output range. I've got my data here. I've got the figure that I made from last week with all of the cover classes, or the proportion cover, and I'm just going to put my correlation matrix down here. All right, tell it where to put it, and hit OK. Now what I get is this big table here. These are all individual correlations. It calculates it to more decimal places than are necessary. We need no more than 3 decimal places here. But what these are the individual strength of associations for each variable according to each other variable. So I'm just going to kind of click on these columns so that they get expanded a little bit, and then I'm going to look at the values that I see here. Correlation helps you find helps you judge the strength of association between variables. It is not perfect, but it is generally helpful for finding obvious relationships between variables. That is to say, it's easy to, as I have read other statisticians, in the words of other statisticians, it's easy to show an effect relative to nothing, but where correlation breaks down is showing a small effect relative to nothing. But let's look and see what we have. So the way that this is output is in this kind of matrix, and you see that all this stuff is blank here, and that's because all of the information is represented in this kind of diagonally shaped set of values that you see here. So for regeneration, we can see the pairwise correlations for each of the other factors within this data set. And then likewise down here for tree cover, we can see its pairwise correlation for every other factor in the data set, and so on and so forth. But let's look at regeneration. We see a couple of, we see a lot of information here, but in general, what we want to look for are correlations that are greater than 0.3 in this case. Things that are less than 0.3, I'm just going to be straight with you, they're probably not real, or they're probably not relationships that we can conclude exist with a lot of confidence. But the things that are greater than 0.3, those might be real linear associations, associations between these variables. So what I like to do, just to keep things straight, because this table is not an appropriate way to distill this information, but what I want to do is figure out which of these things I might want to pay more attention to. So I'm going to look at this and identify the correlations that are greater than 0.3. So that's this first one, regeneration, and the Shannon's diversity index. That's an index of diversity. Slope had a pretty high correlation, and then there's a negative correlation with herbaceous cover and a positive correlation with shrubs. And what I like to do, just to keep things straight, is I color code them. I just fill in these little ones here. That way, later when I'm building a table that has the relationships that I care about, I know where to find them. So I'm going to look at my other factors here. Understory seems to be correlated with elevation. These are not really the focus here, but I'm going to go through and I'm going to highlight all of these just to be complete. So I got something of a correlation between forest floor depth and basal area. Maybe that makes sense. And let's just scan through here. Here's another one, 0.3 basal area and the herbaceous cover. That one's negative. And then we have the Shannon's diversity index and tree cover, and that one is negative. And here is shrub cover and slope. That's pretty positive. It's kind of interesting. Oh, and we got shrub cover and the Shannon's diversity index. Oh, look, one more. Slope and Shannon's diversity index. It's kind of interesting. And then the herbaceous layer seems to be negatively correlated with the shrub layer. So again, I'm going to highlight all these. That way I can find them later quite easily when I want to make a table. Oh, look, I forgot one. Basal area and elevation. Those were positively correlated in this data set. All right, so that's correlation. And we can go through here and then identify the things that are of interest to us. But let's do a hypothesis test now. So we've got regeneration, which is our focus here. Regeneration is something we want to manage as natural resource managers. It is an important component of forests that helps us sustain tree cover and forest cover. There are many valuable aspects to it. So we might want to know how much or whether we can trust these hints about a linear association. And I should say correlation statistics are facts, but they don't tell us the entire story. They don't tell us how they're a measure of information that's shared between these variables, but they're not always the best metric to make inferences about them. Furthermore, if this thing is linearly related, then we should be able to estimate the slope of that relationship, which gives us a framework for making a prediction. So let's choose one of these. We have regeneration and herbaceous cover. So these are negatively correlated, and we might think, well, that makes sense. Understory plants, herbaceous plants could compete with tree regenerating trees and potentially outcompete them. So let's ask this in a formal way. Is the percent cover of a herbaceous layer associated with the regeneration of trees? All right, and to test that hypothesis, we're going to do a linear regression. All right, so again, the two things that we need here are our regeneration and understory cover. I'm going to select those, and then I'm going to go up here to my data analysis tab. I've got the data analysis. I just did correlation, so it's still there, but I'm going to scroll down here to regression. All right, now this works pretty similarly, but we need to choose the X and Y ranges here. And I'm just going to click on this to make sure that it's choosing the right ones. It's got regeneration here, and then it's got the herbaceous layer, or then it's got, hopefully it has the X selected correctly, and it didn't. So I'm going to select it, and then I'm going to choose an output range. And I'm going to just stick this right next to the correlation that I have here. And it kind of knew that I was going to do that. All right. There's some options here: line fit plots, residual plots. I don't recommend that you use any of those. You don't need these right now. There are some assumptions about these models, namely that the data have a normal distribution. We're going to assume that that is the case here. All right, so I hit OK. All right, and now I've got this dialog here. There's a couple of things here. I've got an R squared. I've got an R squared, and I've got a bunch of information down here. So let's do this first. What we should be able to do here is confirm that our R value, which is the same as it is in the correlation matrix. And let's take a look. So we go down here to herbaceous layer, and we have this negative 0.319 value. And look over here at the R value. Where is it? There's the R squared, adjusted R squared. Oh, there's no R value here. All right, so we are not going to be able to confirm that. What we can do, though, is these correlation statistics are simply R, and then what the regression is going to give you is something called R squared. So let's just go down here. Let's do equals this, and then we can do the little symbol for square, and then square it. And what we get here is 0.1. So let's look over here. All right, these do not match. So there is some problem here. Some problem. I have done something wrong here, and we need to figure out what it is. So let's go back up here and have a look. I've got regeneration, and I've got understory. Well, the first thing that's gone wrong here is that I have regressed two incorrect things. I regressed regeneration with the understory, not regeneration with the herbaceous layer as I had intended. Now, we can go back down here into this stuff here. You can see that the correlation for understory was minus 0.18. So it was not very strong. It was not one of the correlations that I thought may be linearly related. And it wasn't what I had intended to test. But nonetheless, the analysis still gives us an insight into how to interpret these. So first off, now that we've figured out what was actually regressed, let's look and compare the correlation value to the output of the model. Multiple R. This is the R, it's not squared, and it's 0.18. You can see here that it's positive here. It's taking the absolute value. These two things match up. We can then do this again. Let's square this thing and see if it compares with how it compares with the correlation coefficient here. And they're exactly the same. All right. This suggests that there is no relationship between these variables. And the rest of the dialogue here gives us information, a formal test of that. And here's what you've got here and what you need to pay attention to. The R squared values are really helpful, like I say, because you can confirm what you've done here and here. And then what you get down here is some other information about the linear relationship here and how much you can trust it. Before we do that, let's make an XY graph and plot these two relationships together so that we can have a look and see what if we think that they should be positively correlated. So what we're going to do here is we're going to do an XY scatter. All right, gives us some weird stuff here. This kind of worthless title. I'm going to immediately go here and add a horizontal axis and a vertical axis. And what I want to do here is confirm and ensure that I've got the right variables on the right axes. Again, we're trying to predict things about regeneration, and in order to do that accurately, or the way that these, I should say, the way that these hypotheses are structured, the way the math works is we are saying that understory cover will predict the amount of regeneration within a stand. So what that means mathematically is that regeneration is the y-axis and the understory cover is the x-axis. So understory cover is ranging from 0 to 1, and regeneration is ranging from 0 to some positive number. So let's have a look here. Where did Excel plot these two things? Well, it put the cover, we can see this because it's ranging from 0 to 1, it put cover on the y-axis and it put regeneration on the x-axis. That is not what we are testing. We are trying to test the opposite relationship, so we need to fix this. So we're going to, the way you do that is you just click on the data and then you can just grab these things and move them. And now we've got the data structured correctly. All right, always check that and then fill in the detail here. Regeneration, and this is per plot, It's not the best way to do it. You can multiply by 20, and then you have, for this data set, and then you have hectares, and then here you have proportion under story cover. All right. Now what I'm going to do is I'm going to move this thing down to where I've got my regression output. That's down here. And the reason to do that is because this output really isn't going to make much sense without this graph. The relationships that you think you might be seeing in here, or that you might expect to be here based on the correlation analysis, are all of these things work together. The correlation analysis, the regression analysis, and this figure. You're looking at this, trying to understand if linear relationships exist here and how much you can trust them. So one of the nice things you can do in Excel is you can add a trend line here. And this is just going to draw a least squares linear line on your figure. You add trend line, and there are a number of different types you can add. There are some nonlinear ones, and just ignore those. The linear one is the one that you want. You can display the r squared and the equation on the graph. And then let's take a look at this. All right, so the r squared that it gets is 0.0325. That is equivalent to this if we round up. It's equivalent to this if we round up. So everything is consistent. And now what I want to show you are these things here. Let's look at the equation. Minus 4.77. Look at that. Right here in the dialog for coefficients, we find the slope, and the estimated slope, and you can find the intercept as well. All right, we're almost there. Is this relationship significant? In absolute terms, there's a negative relationship between understory cover and regeneration in a plot. What regression is going to give you is a measure of how much you can trust that relationship. So another way of putting this is, do you believe this relationship? Do you believe that these are, in fact, negatively associated? And we're going to skip right to this. All of this other information is helpful in certain contexts, but what we want to know is right here. In fact, it's very specifically, it is this value right here. This is a formal hypothesis test of whether the slope here is statistically significant, and whether there is a significant difference from 0 here. What the test has done is estimated how many times, the proportion of times, we would conclude that there is a linear relationship when in fact there is not. Basically, it's asking how often would we mistakenly conclude that there was a linear relationship here when in fact there was not. So what is the proportion of time that based on a random draw of the data, how often would we find this strength of this particular relation, not this particular relationship, the strength of relationship, and it's about 31% of the time. So just based on a random draw from a hat, we would get the wrong answer a lot if we were to, in terms of whether this relationship is actually different than 0. So what we try to do with these p-values is, in order to have more confidence that a relationship that we're looking at is real, we set this p-value for what is essentially a rejection of the null hypothesis that the slope here is equal to 0. We set it to a small value. What is typically chosen is 0.05 or 0.1, meaning either 1 in 20 or 1 in 100 times we would get the wrong answer based on a random draw. That is to say, rarely would we get the wrong answer based on a random draw. In this case, it's much more likely that we're going to get the wrong answer based on a random draw of the data. And so we don't have any confidence that this relationship is in fact driving the variation or regeneration in a plot. In fact, what would be much more helpful is to go back up here and potentially redo this analysis correctly, looking at the herbaceous layer data and performing a regression there. And of course, this exercise has multiple regressions or multiple simple regressions that are included in it and that we need to perform in order to understand the structure of our data.